Hey everybody, this is going to be our first video for Unit 6. We are going to be talking about radical functions, expressions, and equations in this unit. So we're just going to start off with simplifying radicals, talk about the parts of radicals and whatnot. So in general, right, typically when you see that square root symbol, we just think of it as a square root. But there are other types of roots that we can have. So if you're looking at this, we're going to label a couple things here. This n, this is going to be a number that we call the index, and that's what indicates the root that we're taking. Okay, if there is no index, we're going to assume that the index is 2, which means we have a square roots. Okay, now the symbol itself, we're just going to call the radical symbol. And what's underneath the radical symbol is what we call the radicand. Weird word. I just want you to know what it is. Okay, we're not going to use it a ton, but if it does pop up, just know that it's the stuff that's underneath the radical symbol. So in the past, we have simplified square roots. When we simplify a square root, we said, okay, I'm really just trying to figure out, what's the biggest perfect that goes into 320. Well, that would be 64. So, in the past, we would rewrite this as 4 because it was already there. And then 320, we're splitting into 64 times 5, right? 64 is the biggest perfect square that goes into 320. And what that allows us to do is say, hey, I know the square root of 64 is really just 8. So I really have 4 times 8 times the square root of 5. Which is really just going to simplify to 32 square root of 5. Okay, but we can extend this to cube roots, fourth roots, and so on. So if I wanted to simplify this, okay, now I have a cube root, so I don't care about perfect squares. I'm going to care about perfect cubes. So on that half sheet of paper I gave you that lists the perfect squares, the perfect cubes, the perfect fourths, you're going to be looking at the perfect cubes. So we need to figure out, okay, what's the biggest perfect cube that goes into 108? Well, it's going to be 27. So I'm going to rewrite this as 3 times the cube root, don't forget that index, of 27, times the cube root of 4. Okay, and it's 4 because 27 times 4 is what gives me 108. And now we're just going to simplify. So the cube root of 27, this is going to really just turn into 3. So I end up with 3 times the cube root of 4. So I end up with just 9 cube root 4. So it's the same process, we're just using a different set of numbers, right? We're working with perfect cube numbers because we're dealing with cube roots instead of perfect squares. Okay, we only care about the perfect squares when we're dealing with square roots. So let's look at a fourth root one real quick here. Okay, exactly the same process, we're just dealing with perfect fourths now. I need to find the biggest perfect fourth that's a factor of 2592. So that number is going to be 1296, and 1296 times 2 is what gives me 2592 here. So we're going to write this as 5, because it was already there, times the fourth root of 1296, times the fourth root of 2. And now we can actually take the fourth root of 1296 to get 6. That fourth root of 2 is staying here. And we end up with 30 times the fourth root of 2. Okay, I can't stress enough how important it is to make sure that you are keeping the correct index throughout that problem so that you don't forget what kind of root you're taking. Okay, if you mistakenly forget to write the 4 and now it's a square root, that's pretty different than the fourth root. Okay, so make sure you are keeping the fourth root or whatever the index is at the beginning, you're carrying that throughout the rest of the problem. So let's look at what we do when we have some variables. Now, To be able to simplify a radical that has variables, I need to get the exponents of those variables so that they are divisible by the index of the radical. So in this case, since I don't have an index written, I can assume that it's 2, so I have a square root. So not only are we going to be breaking down 324, okay, but we are going to be trying to make it so I can take the square root of a cubed and b to the 7th. So as normal, we're going to be splitting this into 2 square roots. The one on the left is going to be the part that we can actually take the square root of. And then on the right side, we're just going to kind of put the leftovers, the things that don't actually break down. Now, I know that 324 is a perfect square, so it can be square rooted. I'm going to put all of it over here. But if you look at our exponents, okay, neither of those are divisible by 2. So I'm going to make a cubed really a squared times a. And I'm going to turn b to the 7th into b to the 6th times b. What this is going to allow me to do is, over here, I can now divide those exponents by 2, so that this whole chunk here turns into 18, a to the 1st, b to the 3rd, and then I have this square root of ab left over. Let's look at one more like that. All right, so again, I've got a cube root, I've got some variables, I've got a number, so let's split this into 2 cube roots. Part that can actually be cube rooted and the stuff that's left over. So for 56, that's going to split into 8 times 7. Okay, 8 is the biggest perfect cube that's a factor of 56. And then I need the exponents of my variables to be divisible by 3. So r to the 8th, I'm going to turn into r to the 6th, right, because that's divisible by 3, times r squared. And then s to the 4th will be s cubed times s. So now on the left-hand side here, we can take the cube root of 8 to get 2, and then divide our exponents by the index to get r squared, s to the 1st. And we're left over with the cube root of 7, r squared, s. Now, one final note that's important here is when we are working with these different types of roots, okay, we can take the roots of negative numbers if the index is odd. If I have the square root of -4, okay, we said that that means we have imaginary numbers involved. That would turn into 2i. But if I have the cube root of a -8, okay, I'm just trying to think, okay, what number cubed would give me -8? Well, I could do -2 times -2 times -2, and that's going to give me a -8. So that means the cube root of -8 is -2. So anytime you have cube roots of negative numbers, you're just going to get a negative answer. You're not going to have imaginary numbers involved. All right, that is it for this video. Let me know if you guys have any questions, and have a wonderful rest of your day.